Hello, Dr. Debra and Ms. Chua. I am Ika Farana and I will presenting for part 1, which is construct a graph and make a comparison for relative frequency and cumulative relative frequency for both metrics. Before we construct a graph, we need to create a table to find the relative frequency and cumulative relative frequency for both metrics. For relative frequency, we just divide the frequency by the total value. Then for cumulative, we just sum up all the relative frequency that we already count. As we can see here in the table, for the number of visits and the number of purchases, after we calculate, we can create the graph for both metrics. For relative frequency, we use a histogram graph. As we can see here, both graphs shows a decreasing trend from higher relative frequency to higher range, but decreasing to the right tail, which is indicating positive skewness. Next, for cumulative relative frequency, we use the OGIF graph to indicate the cumulative relative frequency for both metrics. For the number of visits, a distribution is considered positively skewed when the tail on the right side is longer or fatter than the left side. The cumulative relative frequency for the number of visits increases more slowly at first and then accelerates, while the cumulative relative frequency for the number of purchases increases more slowly initially and then accelerates, indicating a longer right tail in the distribution. To understand the relationship between two metrics, we can observe the corresponding upper limit. At 20 visits, the cumulative relative frequency is 0.0. At 140 purchases, the cumulative relative frequency is 0.27. As visit increases, so does the cumulative relative frequency for purchases. This shows a positive relationship for both metrics, as the number of visits tends to be higher and the cumulative relative frequency for purchases also tends to be increases.
For part 2, we need to calculate and compare the measure of central location of each data set. First, we have to find mean. To find the mean for number of visits, after we sum of all the value, we need to divide by 30, which is the number of value, and we will get 37.13 million. While for the number of purchase order, the mean is 166.817 million. From the result, it's obvious that the mean for number of purchase order is higher than the number of visits. Next, we need to find median. To find the median of each data set, we need to arrange the number of visits and the number of purchase order from the lowest to highest. First, the number of observation for the number of visits is even. Then, we need to take the average of the middle value, which is position 15 and position 16. We sum up and divide it by 2, we will get 34.5 million. Same goes to the number of purchase order. We will take position 15 and position 16. Sum up and divided by 2, we will get 163.9 million. The results show that the median for the number of purchase order is higher than number of visits. Lastly, we need to find mode. For number of visits, the mode is 34.1 million since this value appears most often. For number of purchase order, there is no mode since there is no value that appears most frequently.
Hi, my name is Kelly Ong Hui with metric number BB22110134. Now I am going to present part 3 in this assignment. The percentile I calculate in this assignment is 25th, 50th, and 75th. Before calculating the percentile, we have to locate the position. The position of 25th percentile is 7.75, which means that the 25th percentile is located 70 5% of the distance between 7 and 8 observations. Therefore, the answer for 25th percentile is 31.95 million. Next, I use the same formula and method to calculate the rest percentile for both metrics. You may pause this video to have a further look at the calculation because I am not going to explain the detail for every percentile. Here is a summary for both metrics. From the summary table, we can know that the 25th percentile for number of visits is 31.95 million, which means that 25% of observed number of visits is below 31.95 million. The 50th percentile for number of visits is 34.5 million, which means that the 50% of observed number of visits is below 34.5 million, while 50% of observed numbers of visits is above 34.5 million. Next, the 75th percentile for number of visits is 45.425 million, which means that the 25% of observed number for visit is above 45.425 million. There is the same interpretation concept for the number of purchase order. Before construct a box plot, we have to know the following value, which is the minimum value, quartile 1, quartile 2, quartile 3, maximum value, and outliers. So to check whether there is an outlier or not, we have to calculate the upper limit, lower limit, and the interquartile range. From the calculation, we can know that the lower limit for the number of visits is 11.74 million, while the upper limit is 65.64 million. However, the minimum value for the number of visits is 23 million, while the maximum value is 54.2 million. It means that there is no outlier. There is the same method to figure out outlier for the number of purchase order. The box plot on the left-hand side is for the number of visits, while the box plot on the right-hand side is for number of purchase orders. Both of the box plot is positively skewed. It's known as skewed to the right because the mean is greater than median. It means that the data constitute higher frequency of high value. That's all for my part. Thank you.
Hi, my name is Mirabeto Inting. My mention number is BT2330624. I'm going to talk about the part 4. Next is the range rate is a simple measure of dispersion. It is the differences between the maximum value and the minimum value. For the number of visits, the maximum value is the shopping, which is the 54.2 million, and the minimum value is PG Mall, which is 23 million. The rate of the number of visits equal to 54.2 million minus 23 million equal to 31.2 million. For the number of purchase order, the maximum value is Shopee again, which is 231.9 million, and the minimum value is Signature Market, which is 116.5 million. The rate of the number of purchase order equal to 231.9 million minus 116.5 million equal to 115.4 million. The number of purchase orders have higher value for the range, indicating it has more diversion with each respect to its minimum and maximum values. Next is the mean absolute deviation, MAD. It is an average of the absolute differences between the observation and the mean. The sample map formula in some of the modulus data value in the set minus the mean divided by the number of data value in the set. The sample map of the number of visits equal to 223.43 divided by 30 equal to 7.45. Sample mean absolute deviation of number of purchase orders equal to 769.74 divided by 30 equal to 25.66. We consider the sample map of number of visits has the smaller value for the map than the number of purchase orders. It indicates that it has a less dispersed data set. Next is the variance and standard deviation. Variance is defined as the average of the square differences between the observation and the mean. The formula is sum of the data value in the set minus mean square divided by number of data value in the set minus 1, where the standard deviation is square root of the variance. The variance of number of visits equal to 2260.98 divided by 30 minus 1 equal to 76.1 million square. Standard deviation of number of visits equal to square root of 76.1 equal to 8.72 million. Variance of number of purchase order equal to 28,640.24 divided by 30 minus 1 equal to 987.59 million square. The standard deviation of number of purchase orders equal to square root of 987.59 equal to 31.13 million. Based on the measure so far, we can conclude that the number of visits has less dispersed than the number of purchase orders. With financial data, standard deviation tends to be the most common measure of the risk. Therefore, the investment risk of the number of visits has lower than the number of purchase orders over these 30 e-commerce websites. Lastly, coefficient of variation is a relative measure of dispersion and adjust for the difference in the magnitudes of the mean. The formula is standard deviation divided by the mean. The coefficient of variation on number of visits equal to 8.72 divided by 37.71 equal to 0.23. The coefficient of variation on number of purchase orders equal to 31.43 divided by 166.82 equal to 0.19. Even though all other measures of variability shows that the number of purchase orders have more dispersed than the number of visits. The coefficient of variation indicates that the number of visits have more relative dispersion.
Greetings to Dr. Deborah and everyone. My name is John Carey with metric number BB22110102. I'm here to present about 5 calculate and interpret the measure of association between the two metrics. There are two kinds of formula to calculate covariance and correlation, which are using sample or population. In this case, I'm using sample formula to calculate both covariance and correlation, and the question mentioned about it was the collected data on a sample of 30 e-commerce companies in Malaysia. For covariance, the formula is the summation of xi minus x bar times yi minus y bar divided by the sample size minus 1. According to the table, the total of xi minus x bar times with yi minus y bar is equal to 5,130.36 million, and the number of samples is 30, so the sample size minus 1 is 29. Thus, the calculation is 5,130.36 million divided with 29. As a result, I had calculated that the covariance between the traffic and conversion is 176.91 million. The positive value of 176.91 million for the covariance indicates a positive linear relationship between the traffic, the number of visits, and conversion, the number of purchase orders. Next, for the correlation, the formula is covariance of the two metrics divided by the standard deviation of data x times with standard deviation of data y. According to the last part, we have calculated the coverage between the two metrics is 176.91 million, and the standard deviation of x is 8.72 million, while standard deviation of y is 31.43 million. So, it's equal to 176.91 million divided by 274.07 million. Thus, the answer is 0.65. The correlation coefficient between the traffic number of visits and conversion number of purchase orders is computed as 0.65, which suggesting a moderate positive linear relationship between the two variables. As the number of visits and the number of purchase orders is positive correlated, thus when the number of visits increase, the number of purchase orders will increase also. That's all for my part. Thank you.